Colby, math.com.
On this assignment, we're finding the prime factorization and sorting into Venn diagrams to find the greatest common factor and least common multiple. You can use your prime factorization to simplify fractions. You can use your least common multiple to find the lowest common denominator when you're comparing and ordering or adding or subtracting fractions. And that's what we're going to do on problem number 6, because on problem number 6 we need to find the perimeter of the decagon, so the 10-sided polygon. And this is a concave decagon because it has some internal reflex angles. Some of these sides are sort of like caved in. When you hear concave, that indicates some internal reflex angles. And there are 10 sides to this 5-pointed star, and we're going to use some of the congruent sides to our advantage when we add up all the 10 sides, because some of these sides are repeated. In other words, there are 2 of these sides that are 5 and 7/16 centimeters long, and there are 1, 2, 3, 4 sides that have a side length 7 and 11/24 centimeters, and there are also 4 side lengths that have a length of 6 and 3/40. And then you might be used to turning these into improper fractions, but that's going to be a lot more work than is necessary, because 5 and 7/16 is 5 wholes plus 7/16. So if I distribute this factor to both terms, 2 5s is 10, and 2 times 7/16 is just 7/8, because the 2 in the numerator and the 16 in the denominator have a common factor of 2. If I distribute this 4 to both terms here in this mixed number, 4 7s is 28. And just to convince you on the side, in case you're not seeing what I'm doing, 11/28, 4 times 11/24. If you express this as an improper fraction, you have a common factor of 4, and 4 divided by 4 is 1, and 24 divided by 4 is 6. So all I'm doing is distributing that 4 to both terms. Same thing here, 4 6s is 24, and 4 multiplied by 3/40, well, 4/40 is a tenth, so I just have 3/10, 24 and 3/10. And the nice thing about realizing we can do that is that now my denominators are still unlike, but smaller numbers to deal with. If you find the least common multiple of these denominators, you can do it, but it's a lot more work. It'll still work out correctly, but you'll have extra simplifying to do at the end. And so what I would propose we do now is recognize that if what we're ultimately trying to do is add these together, 10 and 7/8, and 28 and 7/6, and 24 and 3/10. And there's oops, little issue here, sorry. And then just combine like terms, just combine the wholes. 10 and 28 is 38. 38 and 24 is 62. Then we just need to add these fractional parts and we'll have our whole perimeter. And so we need a least common multiple for 8, 6, and 10. So over here I'm going to do some factoring. 8 is 2 times 4. 4 is 2 times 2. 6 is just 2 times 3. 10 is 2 times 5. If I set up a Venn diagram for these 3 denominators, 8, 6, and 10, they all have a common factor of 2, so that goes in the intersection of all 3. There are no shared prime factors for any of them at this point, and so in the 8 only section I'll put the remaining 2 2s, in the 6 only section I'll put this 3, and in the 10 only I'll put this 5. And so the least common multiple, I think the easiest way to do this one is to use this 10 to our advantage. So 2 times 2 times 3 times 10 is 12 times 10, or 120. The least common multiple is 120. And so that means all of these denominators can become 120ths. 7/8 multiplied by, this is how the Venn diagram also helps you. If you look at the 8 circle, how many 8s equal 120? Well, whatever's outside the 8 circle, 3 and 5, 3 times 5 is 15, so 15 8s equals 120. So when I create this lowest common denominator of 120, I'm just multiplying by 15 15ths, which of course is just 1. So I'm not changing the value of 7/8. I'm just representing it in an equivalent but different looking way. 7/15 is 105. So do that with 7/6 and 3/10 multiplied by some version of 1 in order to get each of those in terms of 120ths. And try to use the Venn diagram to your advantage like I just did. If you weren't sure what I did, you can always back up the video a little bit. Find these equivalent fractions, complete the addition, and then make sure your answer is in simplest form, and come back after the pause and see how you did.
Paused.
If I want to turn 6 into 120ths, that's easy to see that it would be 6 times 20, but just to show you that you could use the Venn diagram, here is 6, and outside of the 6 circle are 2 2s and a 5. Well, 4 times 5 is 20, so we multiply by 20 20ths, we get 140 120ths. Obviously 10 times 12 is 120, so 3 times 12 will be 36. But also if you look at the 10 circle, outside of the 10 is 3 times 2 times 2, which is 12. And so when we add these three fractions, now that they're all like terms, they're all 120ths, we get 245 plus 36. This is how many 120ths we have. That's 11, 8, and 2. Why do I feel like that's wrong? I did something wrong. What did I do wrong? Okay. Well, if you're watching closely, you may have noticed that for some reason, when I did this distribution, this should have been this should be 11/6. That doesn't change things too much. We just need this improper fraction now to be 220 120ths, not what I had. And so now when I add these up, I get 325 and 36. It's 361. So the sum of these three fractions is 361 120ths. Well, that's 360 120ths and 1 120th, because this is 3 wholes. So I have 62 wholes and 3 wholes and 1 120th. So the perimeter of this concave decagon is 65 and 1 120th centimeters. That was a pretty tough problem. The other thing I want you to see before we finish this video, if I can find there we go. I just want to get you started on this one. This one's optional, but if you have time to do it, using each number, I'll count each one of these parts as 2 bonus points. Using each number only once, use the numbers 2, 4, 6, and 8 to write an expression with 2 proper fractions that have the largest possible sum, the largest possible difference, the smallest possible sum, and the smallest possible difference. First, I'm going to get you started by thinking about all the proper fractions we can make. Of course, proper fractions are less than 1 whole. If my numerator is 2, my denominator can't be 2 because that wouldn't be a proper fraction. That would be one whole. But I can make 3 different proper fractions using 4, 6, and 8. 2 fourths, 2 sixths, and 2 eighths. If my numerator is 4, I can't do 4/2 because that would be improper, but I can do 4/6 or 4/8. And if my numerator is 6, I can only do 6/8. I can't make a proper fraction with 8 in the numerator using these digits. I would recommend, if you're doing this, the next step would be to convert these all into equivalent fractions with like denominators, so they're more easily compared, and then try to find the two that you can combine to find the largest possible sum, largest possible difference, etc. But keep in mind that the other restriction is that you're using each number only once. So for example, you couldn't do 2/4 plus 2/6 because you would be using the 2 twice. You're looking for something like 2/4 plus 6/8. I'm not saying that's the answer, but I'm just saying you see that each of the digits is used only once. That's the type of thing that they're talking about. Okay, I hope that helped. I know it's a challenging assignment. Thank you for taking the time to watch the video. I'll see you tomorrow.